Morning, all of you. This is Ishwan from CSE Data Science first semester. Uh, Today, I want to explain one of the concept that is characterizing of matrices, characteristic equation, a deep dive into equations. First, explore the essential role of characteristics in linear algebra, their application across various fields, and how they impact engineering and the computer science. First, characteristic equation of a matrix, exploring key concepts in linear algebra. First, definition of characteristic equation. Characteristic equations represent the polynomial obtained from the determinant of A minus lambda I. First definition is the characteristic equation represents the polynomial obtained from determinant of A minus lambda I is the formula of characteristic equation. Next, calculations involved. To find the characteristic equation, compute det of A minus Hi is equals to 0, where the hash are the eigenvalues. First, we are find the eigenvalues. Then after, we want to find the characteristic equation. Applications in mathematics used for solving systems of linear equations and analyzing matrix properties. The main application is uh, using for solving of linear equations and matrix properties. Applications in physics. In the physics also we are using the characteristic equations of matrix in the form of utilized in control systems, circuit design and structural analysis. In circuit design, the characteristic equations is very useful, and then after implications of characteristic equations. Understanding eigenvalues leads to insights in stability, resonance, and system behavior. The main implications of characteristic equations are understanding eigenvalues leads to insights in stability, resonance, and system behavior. Then we go to another slide. Next, characteristic equations and their importance. What is the importance of characteristic equations is understanding eigenvalues and applications. First of all, finding eigenvalues and eigenvectors. These equations are crucial in determining eigenvalues and eigenvectors, which describe matrix transformations. Second point, stability in systems. They play a key role in assessing stability in control systems, ensuring desired performance and reliability. Next, third one, relevance in quantum mechanics. In quantum mechanics, they help determine state behavior and energy levels, showcasing their fundamental importance. And the fourth one is definition of characteristic equation. Characteristic equations are polynomial equations derived from square matrices and essential for analyzing matrix properties. The main definition is uh, the characteristic equations are polynomial equations and which are derived from square matrices. Next, understanding matrix behavior. Characteristic equations provide insights into behavior of matrices, impacting stability and dynamics in systems. Applications in differential equations. In differential equations also, characteristic equations are widely using solving differential equations and aiding in various scientific and engineering fields. In engineering fields also, the characteristic equations are very important. Understanding the characteristic equation, a comprehensive guide to eigenvalues. First, forming the matrix. Begin with the matrix A and subtract 2 to create A minus 2, where I is the identity matrix. Sorry, it is I. Okay. Calculating the determinant. Next, compute the determinant of the matrix A minus I. Set the determinant equal to 0. Next, solving the polynomial. The resulting polynomial equation from the determinant is solved for I given the eigenvalues, where it is denoted as eigenvalues. Example with a 2 by 2 matrix is given here. Then the characteristic equations are also given here for the example. Okay, and then we go to another slide. Understanding the matrices. First, key concepts and example. First, definition of matrix. Already we are learned. A matrix is a rectangular array of numbers organized in rows and columns. What is mean by matrix? Is a matrix is rectangular array of numbers organized in rows and columns. Application of matrix. Matrix can represent system of linear equations and transformations in vector spaces. Square matrix. A square matrix has an equal number of rows and columns. A matrix which has equal number of rows and columns is called as a square matrix. Example of 2 by 2 matrix is given as A11, A2, A12, A21, A22. Is one of the square matrix. Next, characteristic equation. The equation that m minus xi is equals to 0 is a polynomial equation. In the variable x per given m, it is called the characteristic equation of matrix M. You can solve it to find the eigenvalues x of m. The trace of square matrix M, written as TRM, is the sum of its diagonal elements. Okay. Eigenvalues and eigenvectors. Eigenvalues are associated with eigenvectors in linear algebra. Both terms are used in the analysis of linear transformations. Eigenvalues are the special set of scalar values that is associated with the set of linear equations, most probably in the matrix equations. The eigenvectors are also termed as characteristic equations. It is a non-zero vector that can be changed at most by its scalar factor after the application of linear transformations. And the corresponding factor which scales the eigenvectors is called a eigenvalue. What is eigenvalue is the corresponding factor which scales the eigenvectors is called eigenvalue. Next, finding the eigenvalues and eigenvectors of a matrix. Using the example matrix A. So we take the matrix A, the characteristic polynomial. The characteristic polynomial derived from the matrix A is x into 7x plus 10. Roots of the polynomial is x is equals to 5 and 2. Then x is equals to 5 and 2 are represent the eigenvalues. To find the eigenvector, substitute the eigenvalues in the formula A minus xi is equals to 0. It is one of the best example. Then the characteristic polynomial. What is meant by characteristic polynomial is in linear algebra, a characteristic polynomial of a square matrix is defined as a polynomial that contains the eigenvalues as root and is invariant under matrix similarity. The characteristic equation is the equation is derived by equating by characteristic polynomial to 0. It is also known as the determinal equation. Let us look at the definition of characteristic polynomial formula and characteristic polynomial of n into n matrix, method of finding the eigenvalues as well as several solved problems in this article. Okay. Next, properties of characteristic equations. Essential insights for matrix analysis and stability. First, degree of characteristic polynomial. The degree of the polynomial matches the matrix as indicating the number of eigenvalues. Number two, the eigenvalue types. Eigenvalues can be either real or complex or showcasing diverse. Because of the sometimes it will be real and complex or any other because sometimes negative, sometimes positives, integers or any other. Sum of eigenvalues. The sum of all eigenvalues corresponds to the trace of the matrix, linking linear algebra concept. Product of eigenvalues. The product of the eigenvalues equals the determinant of the matrix, providing insight into matrix properties. Similarity transformations. Characteristic equations remain unchanged under similarity transformation, emphasizing their stability. Sixth one, the importance of understanding properties. Grasping these properties crucial for effective matrix analysis and system stability studies. The diverse applications of a characteristic equations. Uh, Understanding their significance across disciplines, stability analysis. Characteristic equation help determine stability in control systems, ensuring system reliability. Next, vibration analysis. Mechanical systems utilize characteristic equations to identify natural frequencies for design optimization. Next, quantum mechanics. In quantum mechanics, eigenvalues from characteristic equation represent measurable observables. Graph theory. Characteristic equations analyze graph properties through adjacency matrices aiding in network studies. Then we go to another slide. Common pitfalls in understanding eigenvalues. There is some of the common pitfalls. There are confusing eigenvalues with eigenvectors. Eigenvalues are scalars while eigenvectors are distinct vectors. Understanding the differences is crucial. Sometimes we are confusing about that. Okay. Overlooking matrix trace. Characteristic equations are valid only for square matrices. Non-square matrices lack eigenvalues and eigenvectors. Only square matrices are only valid for the eigenvalues and eigenvectors. Misapplying the determinant. Accurate determinant qualification is essential for deriving characteristic polynomials correctly. Okay, these are mainly pitfalls. Next, understanding characteristic equations. First definition of characteristic, we already know that formation process to form a characteristic equation, compute the determinant of the matrix minus lambda and is equals to identify matrix, importance of eigenvalues and role of eigenvalues, common mistakes. What are the common mistakes to avoid them? Recognizing and understanding frequent errors in calculations can significantly improve the learning outcomes. Explore matrix characteristic equations now. Join us to explore the essential principles of matrix characteristic equations and their impactful applications in real world scenarios. Don't miss the enlightening experience. Applications. First, principal component analysis (PCA) and dimensionality reduction, where a dataset is reduced to a small number of vectors based on the values of the extracted eigenvalues. Second, spectral clustering, which is a technique based on the eigenspectrum of the similarity matrix of a dataset to reduce data dimensionality as a step before running clustering algorithms such as K-means clustering. Third one, graph theory. Graph theory is network analysis where eigenvalues and eigenvectors are used to partition a graph into communities, embedding the graph into a lower dimensional space for visualization and spectral specification to approximate a graph with similar eigenspectrum. It is totally about the characteristic equation, its definition, applications, and the formula and examples and the formations, the definitions uh, of all the definitions which are related to the matrix, like square matrix and matrix definition and any other. Then understanding of the characteristic equations, the properties, and the pitfalls, and all topics are covered in this video. So thank you for giving this a wonderful opportunity to uh, discuss about the characteristic equation of a matrix. Thank you.